All right, welcome everyone. So building generative AI proof of concepts is one thing, but scaling them to millions of requests while maintaining reliability and controlling your costs, that's a completely different story. So my name is Damian, and today with Ben and Mario, we're going to show you some proven strategies of running production workloads on Amazon Bedrock. And if I only get my clicker. So first, we're going to look at some essential building blocks that you need to get right. Then we're going to look and see them in action through the Intercom story. And finally, we're going to look at some lessons learned. So when I talk to the customers about running production workloads on Amazon Bedrock, there's always 5 aspects that comes into discussion. First one is the model choice, right? So how do I pick the right model for my use case, or even how do I pick multiple models? Because very often your workloads are going to use multiple models for different use cases. Next is how do you bring the data, right? How can you enhance the LLMs with the additional context? Thinking about the scalability and resilience, right? What happens when thousands or hundreds of thousands of requests comes in at the same time? You have to think about capacity, you have to think about availability. So that brings us to observability. What are some key metrics that we need to track, right? How can we track the cost? How can we keep the cost under control? And finally, data security and guardrails. You've heard a lot today about the responsible AI, right? So how can you make sure that the responses that you're getting through the LLMs, they align with your company policies, with your brand language, and so on. So let's dive into those a little bit more. So first is the model choice. So when you think about selecting your models, there's 4 main factors to consider. So intelligence, how much intelligence do you actually need for your application? If you do some complex reasoning task, if you do code generation, then most likely you want more powerful model. But if you're doing something simpler, like maybe summarization, some background processing, then probably something simpler is better and most likely cheaper. Latency. Again, like if you have a live chatbot application, right, no one likes to wait 10 seconds, 20 seconds, 30 seconds for the answer. So you're going to probably pick a more powerful model that's going to give you better latency. If you're building some internal tools, you might actually get away with a higher latency. That brings us to the cost. Are you actually driving revenue with your product or with the feature that you're building, right? Is it internal for productivity improvements, but are you actually driving a top-line revenue? And if so, then again, you will probably be more interested in the best-in-class models. If it's for internal productivity improvements, you might want to control the costs. And do you need to fine-tune how much customization do you actually need to do? In that regard, open source models will be more flexible to that. So obviously, Amazon Bedrock, you're probably going to see a lot of that slide today. But the main message here, the choice is there, right? And you can pick the right model for your use case, multiple models for your use case. With Amazon Bedrock Marketplace, there's 100+ models available. And you can also bring your own models with custom model import and take advantage of some built-in features in Bedrock like guardrails, agents, or knowledge bases. So the second aspect that I want to talk about today is the data integration, right? So when you think about bringing your data, you can kind of think about it as a spectrum, right? On one side, you have your zero-shot prompting, just asking LLM a question. And on the other side, you have like completely retraining your model. And in the middle, we have a RAG, so a technique that allows you to basically enhance the prompt with additional data. LLMs might not know about your company, what you do, about your products, so you might want to bring that information into the RAG. And RAG has become a very popular system because it strikes a good balance between the complexity and the results. So we're going to talk a little bit more about it, right? So if we think about kind of a reference architecture or a sample architecture for the RAG workflow, you will have the data that's going to come in, and you're going to pass it to the embedding model and store it in a data store. right? So in the POC environment, you're probably going to have a fixed chunks. You're probably going to have just one store. But when you're talking about the production workloads, you might have to test a different chunking strategy. For example, do you need to preserve semantic meaning, right? Do you need to preserve table lists or the whole paragraphs? Then probably semantic chunking is for you. In terms of the data stores, do you need multiple indexes, right? Maybe you have a different type of data and they have a different characteristic, different retrieval patterns. So you have to test those out and see which one works for you best. Then we have our user comes in with the question. That question will also be going to be passed through the embedding model. And that allowed us to do a similarity search, right? And then it allows us to retrieve the relevant content. And again, in the POC, you're probably going to retrieve, your top K results, top K chunks. You're going to pass it to the LLM, and you're going to enhance that answer. But in the production environment, you might be interested more in retrieving the data that you actually need. So you might think about re-ranking, or you might think about actually scoring that content to just retrieving the most relevant one. So actually, one more thing. In the preview, we have RAG evaluations in Amazon Bedrock that allows you to evaluate different chunking strategy, allows you to evaluate the content that you're getting back. It allows you to evaluate the answers as well. So you can actually test different LLMs. You can test the different chunking strategy and pick the one that gives you the best results. So when it comes to common RAG challenges, I mentioned a few of them already. The more is better myth, right? So in the POC, we're bringing that whole context. In the production environment, we want to be more selective. The single index trap, again, think about your data characteristic, the retrieval patterns, and decide if you need to have multiple indexes. And the chunking strategy, again, that will depend on the data that you have, but test different chunking strategies as well. So the next one we're going to talk about is scalability and resilience, and I'm going to bring Ben to give us overview.
Lovely. Thank you, Damian. OK, so we have seen that model choice is important, right? You need to choose the right model for the right use case. We have seen how you can integrate your data. There are different ways. One is RAG, the other one is fine-tuning, the other one is distillation. It depends on how you want to do things. Let's talk about scalability and resiliency, which is another strong topic. So there are different ways on how you can interpret this. We can think about inference optimization. So choose the right inference strategy. We're going to talk that in the next slide. But it's basically between choosing on-demand, batch jobs, or provision throughput. Each one has its strength, as maybe some things that you need to interchange between them. You need as well to think, for example, another inference optimization is prompt caching. So for example, if you have a document that you're speaking about with the model, you don't want to reprocess that document every single time that you're going to do a request to the model. So you can actually cache it straight away. You need to think as well about managing concurrent requests. So how are you going to manage when you're going to have a peak amount of time, right? How are you going to manage when there is a throttling happening? So you need to add requests. You need to add retries, right? You need to be able as well to try to understand how is your request. So how is the traffic of how is the shape of your traffic? So in terms of TPM, so tokens per minute, or RPM, so requests per minute. So all of these, you can actually see them, for example, in CloudTrack, which we're not touching in a minute. And this brings to the global deployment. Make sure that wherever you're going to go through with the model is actually available in that particular region. And then make sure to use, you should really use cross-region inference, because it allows you to actually use the capacity among the whole region, so US, Europe, or Asia-Pacific, Japan. The different types of inference that we have is on-demand, provision throughput, or batch inference. You could use only one, or you could actually combine them. It depends on what you're looking for. So typically, when you're in a POC environment, you're starting to build or you're starting to test models, you would typically end up in the on-demand side to start making requests and pay by the amount of tokens that you're actually consuming. Now, for key production workloads that you have, or key features from your production work, from your use case, you might want to use provision throughput, which is basically you're buying model units that only you are going to be using that capacity. So it's only directed to you. And the third way to do it is batch inference, which is more for asynchronous type of workloads, right, where you're not expecting to receive the answer straight away. Okay, so you could combine both of them. For example, you could have on-demand and provision throughput. You could have on-demand for particular workloads which are not key workloads that, for whatever reason, you have thrown in yourself, it's not a big issue. And then the key workloads that you cannot accept that they're going to be down, you're going to go with provision throughput, right? So you can combine both of them. Cross-region inference, like I mentioned, right? So you're basically making from a primary region the call. So for example, US East 1, but then you're not only using the capacity from that particular region, you're actually using the capacity from the whole US side. So it's a very strong advantage because if you have, for example, a peak workload happening, your requests are not only going to be directed to US East 1, but you can as well use the advantage of the capacity of the rest of the US region. Now, the other strong advantage of this is that you can double up to twice your quotas compared to the on-demand side if you're actually calling from one to only one region. So it's another big advantage in this. And well, of course, you pay the exact same price from the primary region from where you're calling from, so on the on-demand side as well, so it's the same price, so you're actually not losing anything. Observability. So you want to be able to track down what's happening, or you want to be able to track down the cost, for example. You want to be able to see how is your latency going, how is your TPM, so your tokens per minute, your requests per minute, per model, for example, as well. So there's a few metrics that you want to be able to track down. That would allow you as well to, by the way, make sure that you have enough quotas, right? Because if you can actually predict your traffic, you can then plan how much quotas you need to increase to make sure that, and you add a 15% on the top, just to make sure that you can actually cope with whatever peak time you have in there. Now, in terms of cost tracking and monitoring, you can use inference profiles. So in inference profile, you can actually tag, and then you can tag per department, let's say, or per use case, and then you can all the way down go to budget and, well, start applying budgets to particular inference profiles, so use cases, and start tracking down the spend of each use case. The other way around as well, so in terms of monitoring, like I was mentioning, is that you have as well CloudWatch to do this, and in a few clicks, actually, very fast, you can have this pre-built dashboard straight away in your AWS account. So you can see that you have different metrics. You have the invocation counts, the input-output tokens amount that you're consuming. You can usually see as well the request per minute, etc. The interesting thing, as you can as well see now the shape of your traffic. That's always important to see. The second thing interesting you can see on the top, I mean, actually on all of them, you can see blue and orange squares in there. The blue is actually, you see US in front, is actually for when they're using cross-region inference. They're actually calling the model for US itself. And below, you're actually calling the model straight away in the on-demand on that particular region only. Security, always important. I think we never stop about talking about it. Data security, so we never, I think we have said a lot of time where I want to make sure that this is clear. We're never using your data, right? So either the third-party provider don't have access, Amazon is not using data, nobody's using that data, right? Everything is secured in an escrow account, so as the third-party providers cannot access the data that you're sending into their models, you, for example, are not going to be able to directly download, for example, an Anthropic model, right? So we are keeping secure for everyone. Then as well, I don't have, unfortunately, time to go over it, but as well, try to use guardrails, right? The Bedrock has guardrails, so you can actually use, for example, detect hallucination. You can avoid some topics. You can avoid delivering harmful content to your users. All of that is available via Bedrock guardrails. This being said, I'm going to pass now to the amazing Mario in here.
Hey, thanks. Hello, everybody. Just to check the room, how many people are using Bedrock already? Okay, good amount. How many people are planning to use it soon? Okay, not bad. Cool. Okay, so I'm going to talk about Finn, Intercom's chatbot on Amazon Bedrock. So a little bit about me. I'm Mario. I run AI infrastructure in Intercom. I feel a bit sorry for you because Des has exceeded the full quota of Intercom jokes. So this is the last one. It's not going to be as fun. Doesn't matter. You heard a little bit about Intercom. Intercom builds Finn. We believe it's the AI agent for customer support. I'm going to show you a short video of how it works. So this is a purely informational query. It connects to your help center, gets the answer, shows you where it got it from. OK, cool, but that's 2 years old, right? Yeah, it is. OK, next example. You can actually look into your data. It can parse the data. It can do the action, pause the subscription for you, upgrade you. It can do many different things. Cool. So it can resolve up to 86% of conversations instantly. These are just videos, right? It can be full of shit. So if you go to Fin AI, you can actually import your data, website, whatever you want, and you can try it out. And I think our results show that it's working. So far, it has resolved more than 13 million conversations for more than 4,000 customers, so they believe it works. They're actually checking that it works. Most of customers get more than 50% of resolution rate. So out of all the conversations that sent to our bot, 50% of them never have to touch a human. It's actually the most successful Intercom product ever, which is a very hard metric to beat, by the way. This is the result I really like. Customers actually love it. You could argue a little bit too much. We're in the chatbot business for customer support, but OK. OK, so what I'm going to cover today, I'm going to talk about our tech stack a little bit. Then I'm going to talk about how we develop product, how we got to version 1, where we had no data or data that's not of good shape, how we iterated from V2 to where we are today, the infra support we got right, either by accident or deliberately, and then I'm going to talk a good chunk about how we got to the availability we wanted and reliability we wanted with Bedrock. OK, our tech stack. So Intercom is traditionally Ruby on Rails shop. Okay? It's a weird stack for AI, right? So once we started writing AI, back then machine learning features, we started the Python code base. And you can probably take a picture of these libraries and everything we use, because this is the secret to the chatbot, right? Now you can throw it away. It's actually nothing. This is probably what's more important. Okay. So I'm going to talk about now about how we built the first version and then how we got to where we are. OK, version 1. Before Fin, we had several other bots that were built on previous generation of technologies. None of them were even closely as successful as Fin. And the data we collected with these bots was effectively useless. Okay, so the first version, you build completely on vibes. So we believe we have good product intuition, so we build it entirely on that. If you're starting today, you can actually use more tools. You can generate synthetic data. You can simulate users based on the descriptions of users you think are going to have. So there are more tools available today. But when we started, the LLM capacity was so scarce, you were only able to use LLMs for the most critical things only. OK, we got some things right. The first version was useful enough that people started to use it and pay for it. And I'm going to talk about the infrastructure support we got right that actually got us to where we are. There are specific 2 aspects that came out to be quite useful. One is LLM monitoring, and other one is LLM and transaction logging. OK, this seems very basic. Who doesn't want to monitor LLMs? I'm not even talking about the output. I'm talking about low-level metrics of infrastructure. Okay. Quite a basic advice. But LLM APIs can be super unstable. Okay? And when you take retries into account, actually all the metrics start being really hard to understand of what exact impact it's going to have on your customers. You can get quite far with CloudWatch metrics to get out of the box for Bedrock, but there are 2 metrics that you probably want to track that you don't have supported. One metric is time to first token, and the second metric is time to second and all other tokens, or it's called time to sample a token. So why is that? The unit of work you're giving to LLM is actually not the whole prompt. You give it the whole prompt, but when it's working, it's taking roughly the same amount of time to generate each token, except the first one. Okay. When you have prompts that generate different amount of tokens, it's like measuring the performance of SQL queries that have very different complexities. So the prompt is going to completely define how long your request is going to be. When you start having multiple prompts and we start aggregating these metrics, you can't make any sense out of aggregates. If you track time to first token and time to sample a token, what you get is a pretty good indicator of what's the health of the upstream service. It gives you a good way to compare different providers. This is effectively the ticking metric of the upstream service you're using. Another, again, basic but super useful advice. Can't believe that so many people still don't use tracing. Please use tracing. If you have retries, that's going to explain to you, okay, this is why the request took 10 seconds and not 5 seconds, because there was one that timed out and then another one that succeeded. Okay, second thing, LLM and transaction logging. The reason why I introduced LLM logging is because it was so expensive at start to use LLMs that I really wanted to keep everything they give us. I had no idea what we're going to do with that, okay? So this is completely accidental. The second thing we did was we effectively log all HTTP requests and responses. So everything that goes into services that have any LLM call in there, we just log it. Again, had no idea what to do with it. If you're starting today, you can use many products that you can just connect to your LLM clients. They're going to do it for yourself. We went with something completely manual but simple. Effectively, a Python process logs to a simple log file. A Kinesis agent picks it up, and it goes to Snowflake. OK. Now, if you use Bedrock already, you might know that Bedrock has the invocation logging as a feature. So why did we build anything ourselves? Well, it's actually the wrong layer of logging. What you want to do is this. Instead of logging the materialized prompt, you want to log prompt template, prompt inputs, and generation separately. Here's an example. You don't want to log translate to creation, user said that. What you want to log is just a template with variable placeholders, and then variables that went to the prompt, like target language HR, which stands for creation, and user text Kostelac. Okay, I'm going to explain a little bit later why it's very important. Cool. So we built version 1. Some money started coming in. That's good. We got some indication that people love it. But I forgot to tell you one thing, how we charge for Fin. Okay, so we charge for Fin only if it resolves a conversation for you. Okay. If you don't resolve a conversation for you, the only thing we get is LLM bill. So now suddenly, how much money company is making is not just some slide that you see on the marketing and sales funnel during all hands. It's actually something that you affect every day by changing the code. It became a very much engineering concern. So the question of how do we iterate from the first version without being frozen became a question of how do we iterate without breaking the bank. Okay, so this is where LLM logging became the fundamental pillar of everything. Okay, you still with me? Yeah. Let's go here. So all changes we do go through two-stage process. That's happening every day, by the way. So the LLM logs we have saved somewhere, this is where they come into play. Instead of getting prompts, we effectively get prompt inputs. Then we merge them with a new prompt template. Let's say we are changing the prompt here. It actually works for all kinds of changes. We merge the production captured prompt inputs with new prompt template. Then we put it in an engine which is effectively just send all these queries in parallel to LLM. And what do we have now? We have now thousands of examples that we have to evaluate somehow. So who's going to evaluate that? It's too laborious. OK, so we use LLMs again. So we effectively have prompts that are trying to predict whether the question is resolving the user query. Okay? And then we run these prompts against the outputs, and we get proxy metrics. We had to spend a good amount of time to make sure that whatever we're getting from these LLMs is actually a good proxy for what we care about, but it's definitely doable in our use case. Cool. OK, so this is everything offline. It's not touching users. Once the change passes this stage, which is just a normal development iteration loop, it goes to the second stage. We run these tests we run an A/B test in production. Very classic setup, nothing fancy. 50% goes to production, 50% goes to the new candidate, and then we track real product metrics. Sometimes the backtest will lie because you don't have the real metric, but most of the cases we actually have a pretty good sniff of what's going to work in production and what's not going to work in production. this iteration loop is actually used for all kinds of changes we do. Okay, and one of the changes, one day, an engineer came, tested an entropic model, and figured out that for one of the components we have, entropic models work better. We've had a problem. We had no agreement with entropic. It was not in our list of subprocessor list. We were not able to use it at all. And this is where Bedrock entered the chat. Okay? It seemed great. Okay, so you evaluated it quickly. We are already in AWS. The data is never going to leave AWS, which was very important to us. It serves entropic models. We looked at the history of announcements. When Entropic launches a model, they launch the model. Great, very important to us. And then we got to one very non-technical property that became, I think, probably the deal maker here. Because the data never has to leave the AWS, we didn't have to change any contracts with our customers, which means that we can start using it now. But, of course, there's a but. So we're changing the vendor, which means that there's certainly going to be some integration issues. So when we started using Bedrock and started moving traffic there, the chain calls we had in the main flow of the bot, it led to 1% error rate. It's huge. It's terrible. Like, who wants 99% reliability for technical systems? You probably get fired for that. I didn't. OK, so if you remember the RAG architecture, as you can imagine, Fin has to be the RAG architecture. There are not that many alternatives. You get some picture of that, right? But the reality is, each one of these components is actually many different LLM calls. It's probably like 4 engineers working on each of these steps all the time. So it's a pretty big system. And if any of these calls fail, user doesn't get an answer. They get an error. So that's actually the reason why we had such a high error rate. We had many, many calls. Each of them have to succeed. If any of them fails, you're done. And of course, we get no money. But we already spent money to get to the last request. OK, so we had a pretty big error rate, not a good situation. Getting to 99.9% of reliability that we wanted seemed hard. There's nothing good here, right? OK, so I'm going to talk about how we got there. Spoiler alert, we got there and far further. So if you're running a production workflow, or if you're thinking about one, this is going to be probably quite useful. The first concern that helped us a lot to increase reliability was considering streaming. Okay, so since ChatGPT came out, streaming kind of became the UX paradigm of new wave of AI. If it's not streaming, you question, is it smart at all, right? So we turned on streaming for everything. Okay, if you remember the 2 metrics that I gave you, time to first token and time to sample token, you need streaming to observe them. Otherwise, you're going to get all the tokens at the same time, so you have no way to build a metric. For that purpose, we turned on streaming for everything, and then we found the problem with it. So if you turn on streaming, by default, almost no clients are going to do retries. So if something fails, that's it. It's game over for you. If you stop using streaming, retries can happen on several levels. So by default, if you're using Python, you probably use Bota3. Bota3 is going to retry calls locally, but also Bedrock theoretically has a chance to retry calls within Bedrock if they're failing. That led to like pretty good increase in reliability. So my suggestion is be very explicit about where you use streaming. If people are really pushing to use streaming everywhere in the UI, maybe like try to negotiate that if you're seeing a big error rate. Okay, second thing, cross-region inference. Ben has touched on that already. So when we started using, there was no Bedrock, there was no cross-region inference, which meant that all the calls to Bedrock went within our region. It's for us, US East 1, very busy region, not enough capacity. So if you start using cross-region, you're going to get higher availability, because if one of the region goes down, your calls are just going to be rerouted to a different region. Maybe more importantly, if you're a heavy user of Bedrock, you can get higher quotas. There's a caveat, is that you might experience a higher latency. There is, I don't know, 52 millisecond overhead on using cross-region inference. But you really have to test it for your use case and your model, because it's possible that they're running a different hardware in a different region. So the 100-millisecond penalty you pay at start, time to sample the token is faster, and if you're generating many tokens, it's going to just net out to 0, or you're going to be even faster. OK, provision throughput. Intercom values flexibility a lot. We try to be as flexible as we can on every front of technical strategy. So we started on demand. On demand means you pay as you go. It's the default service on Bedrock you use. But the issue can be is that you're running on a shared pool of capacity with all other customers. That also means that that shared pool can run out of capacity. And when that happens, you get throttles before you hit the quota. So the quota you see in AWS, it's effectively the maximum amount of tokens you can get served and not guaranteed amount of tokens. This is something that surprised me a lot. At some point, we switched to provision throughput for some use cases. In our experience, it was very stable. You get guaranteed throughput, but the model units you can buy are very big. So if you're using a big, chunky model, and if you don't have a lot of throughput that has to go through it, it can be quite expensive. When I'm talking about that being very stable, I'm actually coming back to this chart. So what you can see here is like a snapshot of time to sample the token for our on-demand traffic and provision throughput. The orange line is provision throughput. And you can see that for each token, we save around 20 milliseconds. So for small prompts, it doesn't matter that much. For prompts that generate very long responses, we actually save several seconds just by using provision throughput. You can also see that the variance is pretty low, so you don't experience these big jumps of latency. OK, we want to go further. Like after these three things, after we started using provision throughput, disabled streaming, and started using cross-region inference, we got to the availability we wanted. But because each request is so important to us, because we make money that way, we actually want to push it further. You can push it further by using the fact that model availabilities are pretty uncorrelated things. Okay, so if you see an increased error rate on, I don't know, Llama, it's very likely that other models are quite fine. Now, this doesn't come for free, because if you want to use a fallback model and when the first one fails, you have to adapt the prompt. These prompts are rarely easy to migrate from one model family to another. You can use Bedrock Prompt Optimizer for that, but you still have to test it and understand what exactly is going to be the performance of a secondary model. The second thing you can do is you can serve a model by multiple regions. If you're not using cross-region inference, and if you are sending to one region, when one region goes down, you can direct the traffic manually to a different region. For some models, you can use multiple vendors and so on. And very important, I've started my career in a time when compute was in abundance. I didn't know until we started using GPU that it's possible to ask for an EC2 instance and actually not get it. So managing quota was a bit new concept to me. I never had to manage capacity. You have to manage capacity now. OK, so what's our current state? If you remember, we started at 1% error rate. Now, most of the hours, we effectively have no errors. Because of retries we have and because of multiple regions and providers we can use, we are always able to retry and find somebody who's going to be able to serve our request successfully. What's actually more important, I think, is that the operational mode of the team changed totally. So previously, we were looking at this like constant low radiation stream of errors and trying to figure out, oh, is it a bug in a code? Is it an LM failure? What it is? Now, pretty much all the errors we see are bugs in the code. OK, let's take a look at lessons learned and key takeaways. I think the biggest takeaway for me was that whoever you use, the whole LM serving industry, it's still very nascent. Everybody's super early. It's less stable than probably than other services you got used to. Measure everything. Make sure that you actually understand what you're getting. Because of that, investing in basics pays off pretty well. Timeouts, retries, like basic good engineering practices, I think are paying off here probably a bit more than with other APIs. And then I think Ben mentioned it a little bit. You'll have to analyze and serve different use cases differently. Some of them can be very expensive, like provision throughput. So be careful and deliberate about which solution you apply to which use case.
Yeah, thank you, Matthew. Maybe the last thing that you want to think about is about the 5 dimensions that we spoke earlier, right? So make sure to choose the right model for the right use case. It's rare when one model does everything, right? You want to maybe save costs, so you want to maybe have a smaller model, so you will have to choose the model based on the use case. The second thing, how you're going to integrate your data. There are different ways on how you can do it, as we saw before. You can use RAG to have up-to-date data, or you could use, for example, fine-tuning and other different ways. Think about scalability and resiliency. Again, make sure that you know how your traffic is behaving. That's going to allow you as well to pre-plan for production. So to basically analyze how much TPM, so tokens per minute, and how much RPM you're going to need for your production use cases. And try to add as well like a 15% buffer safety just when you have peak times. We spoke as well observability is important. So linked to what I was saying before, you need to make sure that you see your traffic, how is it behaving. You can add alarms as well in your CloudWatch. See how many input tokens you are consuming, how many output tokens. It can be per use case, as it can be, for example, per model. And maybe the last thing, again, is security. So remember, make sure that your, if it's a chat or whatever use case you have, is secure out there. You can avoid talking about certain topics. You can avoid hallucination. You can avoid having harmful content being generated by the model, etc. All of these, you can use Bedrock guardrails. This being said, thank you very much. We're going to be in the booth.
We're going to be hanging around in Ask an Architect booth. So if you want to come in and ask a couple of questions, please fill the survey. Everyone who fills the survey gets a free pint at the end of the day. You can do it even twice if you want. That's 2 pints.
Covered by Damian, huh?
So thank you again.